Welcome to my fifth and final lecture in the course Research and Financial Markets. The final paper that I would like to discuss with you today is entitled On Industry Momentum Strategies. So this paper is co-authored with James Kolari, which is one of my colleagues. He's professor in finance at Texas A&M University in the United States. So it's published in the Journal of Financial Research, which is also a very prestigious journal in the US and highly recognized. And if you read the paper, you will see that many of the ideas that we have been already discussing are also a part of that paper, basically. So what's the main idea of that paper? So there's a lot of research going on, and what people have found, also myself, including myself, that the standard asset pricing factors that might explain the cross-section of US returns, or also in international equity markets, if you consider, for instance, the size factor, the profitability factor, value factor, and the momentum factor, they obviously describe, to some extent at least, the cross-section of expected returns in different asset markets. But obviously these factors do not explain, or at least very, very little, the cross-section of industrial returns. So there's obviously a sort of a gap in the literature, because there are not so many papers that basically investigate the cross-section of industrial returns. There are only a few papers, and some of them actually are also published in the top journals. So what we do, so our paper basically was influenced from the Farmer and Friends 2018 paper, who basically added the stock price momentum factor to their former proposed 5-factor model, and basically proposing this 6-factor model for pricing the cross-section of stock returns in the US. And what we do in this paper basically is we investigate the asset pricing implications of industrial momentum for pricing the cross-section of industrial returns in the US. So first of all, we need to discuss a little bit about momentum strategies. How does it actually work, or how does industry momentum work? So first of all, we have sort of as assets, or as input assets for compounding our strategy, we use, instead of stocks, we use portfolios, in industrial portfolios. And on the web page from Kenneth French, you will find, for instance, 48 portfolios, value weighted, and these portfolios are sorted, or basically, they are sorted into 48 different industries. You also have a set of 10 different industrial portfolios, or 5 industrial portfolios. But in our paper, we use the 48 value-weighted US industrial portfolios. So, and then basically, the way how you calculate momentum is straightforward. So let's consider J, L, and K strategy. Where J is basically the accumulation period, where you compound the cumulative returns of your input assets. L is the skipping period, and K is the holding period, or the forecast period of the return. So in our paper, we consider 3 different strategies. So let's check the first strategy. So if this is our timeline T, and here we are in T0, where our asset allocation takes place. So what we do is, we simply take the return of the previous months, T minus 1. And what we do is, we sort all industrial portfolios from winners to losers based upon the return, the simple return of the last month. So what we do then is, okay, we buy the industries that have been best performing, and we are selling those industries that have the lowest return in the last months. And of course, there are different ways how to do that. We were operating with quintiles, which means we have 5 groups. So we are dividing the 48 industry portfolios into 5 groups. And each of these groups have 20% of these 48 assets. So again, we buy those industrial portfolios, those 20% of industrial portfolios that have the highest return in the previous months, and we short sell those 20% of industrial portfolios that have the lowest return in the previous months. So we keep these portfolios, or our zero cost portfolio, constant 1 month ahead. Which is our holding period. So our accumulation period is 1 month. We do not skip any month, so that's 0, and K is 1. So because we have a 1 month holding period. So this is then the so-called 1-0-1 strategy. We also consider another strategy. Again, we have our timeline. Here is T0, like in the earlier case. So, but in this strategy, we accumulate the returns of our 48 assets from months T-1 until month T-6. We skip 1 month in between, and again we keep this portfolio 1 month ahead. So the strategy works, of course, in the same way. So for all 48 valuated industrial portfolios at time T0, we compound the cumulative returns from T-1 until T-6. We buy those 20% of valuated industrial portfolios that have the highest cumulative returns given this period here, and we finance this position by selling those industrial portfolios that had the lowest cumulative return given that period. Again, we have our zero cost portfolio strategy and our asset allocation, and keep that portfolio 1 month ahead, which is our holding period return. So in this case, our strategy is the so-called 6-1-1 strategy. So we accumulate from J is -6 until T-1, and we skip 1 month. So this is this guy here. We skip this 1 month, and we keep it 1 month ahead. So this is the 6-1-1 strategy. Obviously, these two strategies here, they are formed on different sets of information. So this strategy here, the 6-1-1 strategy, obviously exclude this 1 month. So this strategy here is somehow controls for that strategy because it excludes this 1 month. So the final strategy that we consider, now we did a little bit longer timeline, obviously. So in this, again, we start at time T0, but now we compound the returns from the cumulative returns from T-1 until T-12. Until T-12. Again, we compound the cumulative returns for our 48 valuated industrial portfolios. We buy the 20% of these portfolios that had the highest cumulative return within this period, and we finance this position by selling those 20% of valuated industrial portfolios that had the lowest cumulative return in this period here. Again, we keep our asset allocation 1 month ahead, and this is T+1, obviously for all of these it's T+1, so we investigate 1 month holding period. So the strategy is then denoted as 12-1-1 strategy. So these are the 3 industrial momentum strategies that we discuss in this paper, and we investigate the correlation patterns of the strategies here. How much are they correlated? We also investigate a risk-managed counterpart. And in this paper we focus on the 101 strategy, because obviously in an earlier paper with two colleagues, we were focused on this standard 12-1-1 strategy. Let's take this away. So using this short-term industrial momentum strategy, let's denote the returns of that strategy as R101 as our strategy at time t, and let's denote here comma Rm, which means risk managed, is equal to a scaling factor C, we know this already from our earlier paper, divided by sigma square hat t minus 1 times the return of the standard unscaled strategy. Yeah? So we have again, it's a similar formula as we have already discussed in an earlier paper. So we have here the scaling factor, where we basically scale the standard 101 strategy. We multiply it by this scaling factor here, where we basically divide again a constant C, which is our target level of volatility, by the past volatility of the previous months. And this is the same formula actually that we have discussed in the paper on volatility managed strategies. And in contrast to that paper, what's the difference? Well, we do not compound the realized past volatility of the month t minus 1 using 22 daily observations, but we use the exact number of observations. So sometimes we have 22, 23, 24, sometimes we have only 17 or 18 observations to estimate our previous month's realized volatility of that corresponding strategy. So the data, as I said, is downloaded from the Kenneth French webpage. So that's basically what we operate with. Moreover, we are setting the target level of volatility, this C here. C is equal to 12%. So the choice is somewhat arbitrarily, and this is basically what we have taken from another paper. So the choice in the earlier paper from Moreira and Moore, the 2017 Journal of Finance paper, they argue that the choice of the target level of volatility, the C, obviously has no impact on the Sharpe ratio. So that's why we chose basically a constant, the target level of volatility corresponding to 12%. What we do also then is, of course, so we control, we conduct or we implement regressions for a risk adjustment, where we then regress the risk managed counterpart on the standard strategy. Again, our regression model looks then like this. So we have the risk managed strategy, and we regress it on a constant term alpha plus beta 1 times this unscaled strategy, and because it's a regression equation, we have to include error term as well. So, and then whenever our alpha is positive, we remember this means that adding this factor to this factor increases the mean variance frontier. So whenever this intercept is 0, then we say, okay, obviously we have a higher, or we have a risk-adjusted return, unexplained, which is unexplained or in excess of the unscaled factor. So in this case, we would conclude risk managing for that factor makes sense because it increases the mean variance frontier. And of course, as usual, we perform different kind of robustness checks. This is also something obviously that you are asked to do in your master thesis. You have to make sure that your results also hold if you basically control for other sources of risk. So we also investigate models where we basically then add as a control variables, for instance, the market factor are in excess form, of course, RMT, or the size factor,